This is Josh White with JW Math Tutoring. In today's video, I'm going to cover 10 problems from the June 2026 Digital SAT Math exam. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I begin going through these 10 problems from this June 2026 Digital SAT Math official test worksheet number 1. I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, please check out the videos for part 2, which will have 10 other new problems. And also part 3, which will cover all the repeat problems. Basically, problems that we've seen and I have solved previously, oftentimes on multiple occasions. So that video is just going to basically highlight or touch on these problems, but it's not going to have the full solutions like this video would. Also, you can find a link to the worksheet for these problems in both the description of the video and in the pinned comment. And in the pinned comment, you can also find a link to the Excel spreadsheet, which has basically descriptions of all the problems from my official test, playlist video series. And you can sort it, you can filter it, you can search by, specific type or topic, basically. And there's also a PDF version of that as well. It's also got individual links to all the videos on one of the tabs in it, and also links as well to the alternate solution videos, which are made after the original videos are posted, and generally work on suggestions or alternate solutions from commenters on the channel. One last thing just keep in mind too. So I've tried to recreate these problems as best as possible based on what people have reported, but it could be a problem you see here is slightly different than what you experienced if you took the June test. So just please keep in mind there might be variations between the problems you see here and one that you got on your official test. I've tried to make these again like as workable or as possible, but I don't have a copy of the test in front of me, so there might be, like I said, minor differences, or I guess possibly major differences between a problem you saw and what you see here. All right, so with all that being said, let's go ahead and get started here. June 2026 Digital SAT Math official test worksheet number 1. Okay, the first problem is the sweater problem. So the whole idea here is you have the store, it's selling sweaters, there's a regular price, there's a % discount off the sweater, but that % varies based on how many sweaters are purchased. Then there's also a flat discount amount, fixed dollar amount, basically coupon, you could think of it that way, that comes off the price of each sweater as well. Okay, so the way, basically the way that you're going to set up the equation for this, if you're going to solve, if you're going to solve this by hand, would be something like start with 44. Okay, that's the original price. Then we're taking off n% of it. So if you're actually writing it out, you would do something like this. You take n divided by 100. That's n% converted to a decimal, and that's multiplied by 44. Okay. Now, so this is the amount after the n% has been taken off. Then you also are going to subtract 4 from the price as well. And then you have to multiply this. So this is basically the price of the sweater after all discounts are applied. But we then have to multiply it by the quantity to get the total, cost, essentially. Total amount, dollar amount for the order. So you have to multiply by n as well, and then you can just set that equal to 804. So I'm not going to bother going through and doing all the algebra work by hand to solve this. I would say at this point, we can just go to Desmos, and we can just, basically type in a regression, and then I'll also show you a couple things that you could change as well. Let's put actually not a bracket here, let's put this here. So there's the price. We're multiplying by the quantity that is purchased, and then set it equal to the total order cost. Okay, So you get 30. That is the correct answer. Okay, and basically that's essentially the problem. Now, two things. First, you could back solve this, since I believe this question was multiple choice. So what I mean by that is you could set up this expression, and here's another thing too. If you're going to actually just go straight to Desmos instead of writing it by hand, you don't need to do n over 100. You can do n% of, the 44. So now, like I said, if you were, so first of all, just real quick, sorry, if you're going to solve this just strictly in Desmos, you could just do it this way. You don't have to do n over 100. That's just one thing I want to point out. But the second thing is, if you wanted to back solve this, you could just set up this equation, right? And then you just go and you just check, okay, 25, what do I get? Is it 804? No. 30. Do I get 804? Yes, that's the correct answer. And then you could check 35, but that's obviously wrong. And you could check 40, but that's wrong as well. So you could plug in the answers as well just to confirm, that letter B, 30, is going to be the correct answer. Okay, now let's take a look at problem number 2. This problem involves factoring, and if you have already looked at my Ultimate Desmos Guide to Digital SAT Math, then you should be familiar with how to factor expressions in Desmos using regression, and specifically these types of problems. However, one little wrinkle that this problem has that not all of them do for this specific type is that there's a common factor, a GCF, that you must factor out in order to solve it correctly. So I'm going to go to Desmos and basically just solve this straight in Desmos. Then I'll just briefly talk about how you would do it if you want to solve it by hand, but it's so much faster and easier just to solve this in Desmos. So what I'm going to do, actually, let me just move down so I can get make the Desmos window as large as possible, because we're going to have a bunch of different things to type. Okay, so first thing you could do is go ahead, type in the original expression on the left. Now, you always want to check and see if there's a GCF between all the coefficients. In this case, there is. Up here, now you could define this as a letter, or you could just type 3 up here. Either way is fine. Then I'm going to type my factors. All right, now I'm going to add my element list for x1. All right, notice it's giving me decimals for A, B, C, D, okay? But they should be integer values. So what you have to do in this situation now is we need to go ahead and we have to basically start defining values for A or C, either one. And those are basically going to be factors of the A value in the original expression, except because I factored out a GCF, in other words, because the GCF was 3, really what I'm factoring looks like this, 71x squared plus 35, just this part inside the parentheses. So really, I'm looking at factors of 24, which are 1, 2, 3, 4, 6, 8, 12, 24. So what we need to do now is basically start with 1 and then go through and look for when do I get all integer values. I didn't need to do 5 there. For B, C, and D. Notice that happens when I set A equal to 8. So now that I've done that, I can check my values. And what you need to look at here, obviously you need to look at AB, but you also have to look at CD. In the problem, when it talks about like the smallest possible value of AB, it's not specifically asking for whatever numbers Desmos assigns to A and B. It's asking for the smallest product of the coefficients from either parenthesis. So it doesn't matter that which parenthesis officially is A and B and which one's C and D in your regression. That part is irrelevant. The point is you have to check both parentheses here, i.e. both factors, and multiply the two coefficients together and see which one is smaller. Therefore, the correct answer to this problem will be CD, which is 21. Now, just to briefly mention, if you were going to factor this by hand, like first, okay, you would factor out the GCF of 3, and then you have this like long giant thing to factor. If you try to use the AC method, well, 35 times 24, if I did this correctly earlier, it comes A times C is 840, and you're looking for factors of 840 that add up to the B value, which is 71. Those two factors happen to be 15 and 56. Now, obviously, you're probably not going to know that off the top of your head. You're going to have to do like trial and error, guess and check. So basically, I think it turns into, what is it, 24x squared, or x to the fourth, plus 15x squared, plus 56x squared, plus 35. And then you can go ahead and group these together, blah, blah, blah. Anyways, it comes out to the same thing. It comes out to the 3 out front, then 3x squared plus 7, and 8x squared plus 5. It's the same parentheses. The order here is switched, but that doesn't matter. But you still get the same answer, right? This one is 21. This one is 40. Smallest thing is still 21. Okay, let's look at the next question here. Number 3. This was another very popular question. We have this diagram with 2 parallel lines. By the way, I just realized I forgot to label these in the picture, so I will fix that in. That's probably going to be C. That's going to be D. It's going to be. I will fix and add the labels in the updated PDF worksheet. So these 2 lines are parallel. All right, and we're given some couple different angle measures here, and wants to know which of the following must be true, comparing J and P. So this looks really confusing because there's angles everywhere. Who knows, like how to compare these two things? Like P is way out here, right? J is way up here. However, there's a very simple, easy way to compare these. Look at this triangle right here, okay? And then we're going to compare that to this triangle right here, the green. Okay, in the yellow triangle, we have 3 angles. One of them is 62. The other one at the top here is J. And then this one down here in the bottom corner, we don't know. I'm just going to call it X. All right, now we have the green triangle. We have, in this corner, 56 vertical angle with this given 56. We have also P down here, vertical angle with given measure P. And then notice this angle right here is the same in both triangles. So I'm just going to call this X again over here. So essentially what's happening now is we have 2 triangles, all 3 angles add up to 180. Notice X and X, these are the same. So you can essentially just ignore them. So then it comes down to comparing like J plus 62 versus P, plus 56, right? So you can probably just look at this and realize, well, 62 is larger than 56, therefore J is going to be less than P. You know what I mean? This has to be smaller than that in order for these to equal the same number. But an alternate way to realize that is essentially, you set up an equation like this, right? Notice if I subtract 56 over, I get J plus 6 equals P. Okay, so which one's larger? Well, obviously P. You know what I'm saying? You take J and you have to add 6 to it to get P. Therefore, this is the larger angle. This is the smaller angle. Therefore, J is less than P. Correct answer for this is just going to be letter C. Okay, let's go to the top of the next page now. Take a look at problem number 4. This one basically was a unit conversion problem dealing with converting cubic something, in this case technically starts off as cubic meters, to quarts. So this is a unit conversion, but specifically it's a volume conversion. So I'm just going to set this up and do this essentially like dimensional analysis if you've taken chemistry. So I start off with my original value of 0.07719 cubic meters cubed. Okay, and then I'm first going to multiply that by the conversion factor to go from meters to centimeters, or really, okay, so it's this, 1 meter, 100 centimeters. It's really from cubic meters to cubic centimeters. So what you must do here is you must cube, or you could also write out 3 times, this conversion factor. Okay? That will cause this to cancel out and this to cancel out, and you'll be left with the volume in centimeters cubed. And now you can use the conversion factor of 946.353 cubic centimeters to 1 quart. And we could go ahead and now this will cancel out with this. But remember, actually, let me do it this way. This will cancel out, but we're still cubing the 100 on top. Now we can just go ahead and multiply it through and see what we get. So let's pull up Desmos here. We've got 0.07719 and then times. It's 100 over 1, and that is raised to the third power. And then times 1 over 946.353. Okay, so it comes out to 85.565, blah, blah, whatever. Notice in this problem I've designed, I've said to round it to the nearest quart, i.e. nearest integer, nearest whole number. So that's just going to be 82. That would be the answer that you would type in or that you would fill in. All right, let's look next at number 5. Now this question, I've seen questions like this floating around or mentioned before, but I don't think I've had one exactly like this, in my official test problem set worksheets. Basically what's going on here is you have 3 different types of, in this case it's screws, but it could be anything depending whatever they're talking about. They're different, basically they're different lengths here, 3-inch, 8-inch, 9-inch, okay? And so what's going on here is you have 100 total screws being made, or some number, whatever it is. For one of them, they give you the exact number, which in this case it's 4 9-inch, okay? Then they tell you one of them is basically, the number of them is n. In this case, it's the number of 3-inch screws. That's what's represented by n. So for the 9-inch, there are going to be 4. For the 3-inch, there are going to be n. And then the other one, the 8-inch, is a product or a multiple of like the n, the one that's defined as n. Because notice here it says 8-inch screws is 5 times the number of 3-inch screws. So that means this is just going to be 5n. So these expressions here represent the number of each type of screw. So you can just add all these up, 5n plus n, 6n, plus 4, set that equal to 100. Your answer is basically letter C. Some people will choose A by mistake, but keep in mind in A, what it's doing here is it's taking the number of screws and it's multiplying them by the length of each screw. This is what you would do if the problem was worded such that it told you like the total length of all the screws produced was, whatever this works at, blank inches. And the right side was like number of inches, not number of screws. Okay? Because here you're multiplying like number of screws times inches per screw, essentially. But that's not what the question's asking for, so that's not, not the correct answer to this specific problem. All right, let's look at the next question, the one below it. Here is a radical equation, and you're basically told that there are 2 solutions, and question's asking for the difference between the 2 solutions. Basically, the smaller one minus the larger one. Okay, so if you wanted to do this one by hand, and I would not recommend doing that, I'm going to show you the Desmos solution here in a little bit, but just to review the algebra, you would square both sides. Left side becomes 2x plus 19. Right side becomes 4x squared plus, this is a hook and double. So basically hook these and square them, and then we take the 2 things in the middle and we double it. So that becomes 38 times 2, it's 76x, and then plus 361. Now you get this all equal to 0. It's 4x squared plus 74x plus 342. You can put the equal 0 over here. Now at this point, again, I would not do the work. Even if you did this initial work by hand, I would just go to Desmos and get the solution. The solutions, the roots, the r and the s. So for example, you could just go here and do 4x squared plus 76x plus 361. Now, it's a little tricky here because you have to zoom in pretty far. Wait. that's not, I want to type the one below it, not the initial one. The initial one's only going to have one answer because it's a perfect square. Here's what we're looking for. So here are two roots. Okay, so the smaller one is r, because it said in the original problem r is less than s. Okay, so r is equal to this number, and then s is equal to this number. It's technically the larger number. And now what is r minus s? It is negative 0.5 or negative 1/2. So you could enter it as negative 1/2, you could enter it as negative 0.5, or you could just enter negative 0.5 like this. All of these would be considered correct. Now let's look at how you could solve this in Desmos. I think the easiest way, quickest way just to solve this strictly in Desmos is to use the graphing approach. So I'm going to do graph y equals left side, y equals right side. And then I'm going to look for the intersection values. So I have to zoom out a little bit, then zoom in, and now we can easily see them right here. Here's one, here's the other. Again, I don't care about this. I don't care about this. This is r, it's the smaller root. This is s, it's the larger root. R minus s. Same answer, negative 0.5. Entire problem done completely in Desmos. No squaring, no algebra needed. All right, let's move to the top of the next page. Question number 7. Previously, I had a problem that was very similar to this. Wasn't exactly the same because here you are given the actual equation. In the previous problem that I had, I forget which month it was from. I'll post a thumbnail in the video about it. You were given that there was a solution of this form, and you were given I think you were given both actual numerical solutions, and then it said find the value of m plus n. So this one is similar, but it's not quite the same. So I'm going to show you first how to do this entirely in Desmos. Then I will show you the algebra work, just because the algebra work is kind of a pain here because of the form that they give you the problem in. So all we have to do in Desmos is we need to just type this as this quadratic equation as a function, meaning we need to get it equal to 0. So just move the 15 over to the left by subtracting it. Then I am going to use regression, and basically what I'm going to say is, okay, I have one solution which looks like this, okay, and that is equal to 0. Now notice it's not giving me the correct values for m and n. They're supposed to be integers. What you have to do here is I have to use the conjugate solution, which is the solution that's going to be m minus square root n over 3. And then when I do that, now I get m and n. M plus n is 123. That's your answer. Problem solved. Okay, one slight variation you could also take to this. We'll see how this works. Okay, these are my two solutions. You could also use regression to do the following. You could regress the actual solution values themselves. And of course here, the plus is going to get the larger value. The minus one is going to get the smaller value. Now, because these are not exact values, these are like rounded or approximated, notice that the m value is fine. It's the n value that isn't exactly 126. But hopefully you should recognize that it's still, going to be 123 as your answer. Again, I would not recommend this approach. I personally would use the first approach, which does give you the exact values, but this is just an alternate approach you could take as well. Okay, now real quick, if you were going to do this by hand, I will just show you. First thing I would do is I would distribute this and then subtract over the 15. Okay, so we get it equal to 0. Then we're going to go to quadratic formula. Okay, negative b plus or minus 2 times a square root b squared minus 4 times a times c. All right, so let me just clean up a couple things here. That's 3, that's 18, this is 3. Okay. Next, we do some simplification. Just trying to look at my notes here. The number inside here is going to be 504. And on the bottom we have a 6. First, let's just confirm that. Discriminant value, 18 squared minus 4 times 3 times negative 15. Yes, it is 504. Okay, good. Next, we split this up. Negative 18 over 6 plus or minus root 504 over 6. Okay, well this just becomes negative 3. So there's our m value right off the bat. Okay, m is equal to negative 3. This you have to simplify, but specifically you have to take something out such that the 6 in the denominator will turn into a 3. That means you have to basically take a 2 out of the radical, which means you need a factor of 4 inside the radical. So you have to split 504 up into 4 times something. Okay, so if you don't know it, it's just going to be 126. I mean, you could go to Desmos and just confirm that. So then you've got this under a radical. The square root of 4 is just 2, so it becomes 2 root 126. Wait, leave this here. Okay, 2 root 126 over 6, but then the 2 and the 6 cancel out, and it makes 1 over 3. Now we have our end value of 126, and you could add them and get positive 123. So this is the actual algebra if you wanted to do it that way. All right, let's look at the next problem. This is a pyramid problem. I think we have had problems like this before, but I did want to go over this because A, it's been a little while, and B, in the past, almost all the problems I think we've looked at where you've been given like a total surface area and a base area or a lateral surface area or whatever, generally only dealt with integers. They didn't have roots or radicals in them. So that's why I did want to go over this one or highlight this one. So notice we know the base area here is 36. Okay, that means the side length for this thing is just going to be 6. 6 and 6. Okay, then we've got the height coming down here in the middle. And then also we will have the slant height coming down here on a triangular face. Okay, we also have this is the total surface area, which means this is the area of the 4 triangular faces plus the base. So total surface area, right? 36 plus 12 root 493. Now, to get the lateral surface area, which is just the 4 triangular faces, their surface area, I'm going to take this total surface area and subtract the base area of 36 from it. So notice what happens is these cancel out. The lateral surface area is just this term, this 12 root 493. Okay, so that's the area of 4 triangular faces or 4 triangles. So if I want the area of 1 triangular face, I just need to now divide this by 4. So I get 3 root 493. Okay. So this is the area of 1 triangle. Now, a triangular face is going to have a base of 6, and it's going to have a height of L, the slant height. So this is equal to 1/2 times the base, which is 6, times L, which is the slant height. So if you want to solve this out, essentially notice what's going to happen is 2 goes into 6 3 times, and the 3's just cancel out, and you get the slant height equal to root 493. I mean, if you could do the whole thing, you can do the whole thing in Desmos. It'll just be a decimal that you want to carry through, the exact value for. So now, essentially, to find the height of the pyramid, we go back to this original right triangle that I drew here. And I'm just going to reproduce it. It basically looks like this. Height, we don't know. Leg down here, 3. Hypotenuse, that's the slant height, which is the 493. So now I'm just going to go to Desmos, and I'm just going to type in h squared plus 3 squared tilde square root 493 quantity squared. and it gives me a value of 22. Therefore, the height is equal to 22. That is your answer to this problem. All right, next up, question number 9. Here we have one about survey design and generalization of results. So this problem is a little bit different than some of the other ones that we've seen, because this one is basically asking you for a reason, like say why this study cannot be generalized, in this case to all the middle school students located in the four school districts from which the 100 students that participated in the survey were chosen from. Okay, so the answer to this question is just going to be D. And the whole reason is because if you read this very carefully, notice it says a county selected 100 total school students, blah, blah, blah. Notice what's missing here is the word randomly. Okay? They did not randomly select the students. That is the reason why you cannot take these results and generalize them to all the middle school students in these 4 different school districts. Technically, these results could only be applied or generalized, use whatever word you want, to the 100 students that participated in the study. Doesn't matter, like it has nothing to do with whether the sample size was too small or the actual, size of the sample or about randomly assigning it. That relates to the validity of the study, not to, why you can't explain it to all the middle school students in the 4 school districts, or the fact that maybe there were a lot more 6th grade students in it compared to 7th or 8th. I mean, that is sort of related to not randomly selecting the students, but that's not the real reason or the base underlying reason. It's D here. All right, so next, top of the next page, problem number 10, last problem here on this June 2026 official test problem set, worksheet number 1. Which of these following equations has exactly one solution? So a lot of these look pretty similar. Basically what's going to happen here if we work these out, 3 of the 4 are either going to be infinite solutions or no solution. 1 of the 4 will have exactly one solution, one numerical value. Now, if you wanted to actually do this by hand, which again I probably wouldn't recommend, if you notice what happens in the first one, if you distribute this, on the left side you get 18 over 5x plus 342. So you get the same exact expression on the left, the same exact expression on the right. Therefore, this one is infinite solutions. It is not the correct answer. If you do the same thing to b and you multiply it out, okay, you get 18 x plus 342, same exact thing as the last one. But notice on the right, the x term does not have the same coefficient. The x term has a 1/5. Therefore, this is going to have one solution. This is going to be the correct answer. If you look at C, what ends up happening is these cancel out and you get 19 equals 19. That's another infinite solutions case. For D, if you multiply it out, you end up with 18 over 5x, what's the number, plus 162, 9 times 18. And therefore, this one becomes no solution. The x's cancel out, the x's are the same, but the numbers are not the same. So the correct answer for this one is letter B. Now, let's just go to Desmos to, confirm or show you that. So let me just erase all this here. Okay, so the first one. And what I'm going to do is I'm going to graph y equals left side and y equals right side. And essentially, we're looking for one intersection. If it's parallel lines, it's not the answer. If it's the same line over top of itself, then it's not the answer. Notice here, we get the same line over top of itself. That means it's infinite solutions, not the correct answer. Okay, let's move on to B. Change this to a 1/5 and change this to 19. One intersection right here. This is the correct answer. Okay, just to check, I'm going to check D first, just because that one is much closer to B in terms of like the typing. Notice here it's parallel lines, therefore it's no solution. You can keep scrolling, but they're never going to intersect. And then lastly, let's look at C. Here again, it is the same line. Just notice when I turn it on and off, it's the same thing that you see, so therefore that's not going to be the correct answer either. So again, this one, correct answer is going to be letter B. Alright, so I hope you enjoyed this video. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, make sure you check out worksheet video number 2 to see 10 more new problems from the June 2026 Digital SAT Math exam. Also, check out video number 3, basically that will have just a brief highlight of the various repeat problems that appeared on the exam as well. If you have any questions or comments or alternate solution methods to any of these problems, feel free to leave them in the comment section below, and then eventually I go back and I make alternate solution videos as well. Another thing to keep in mind, check out the spreadsheet. There's an Excel file version and a PDF file version which has all of these official test problems listed in it. I mean, it's not the full problem, it's just basically a general description, but the point is it shows you which ones are repeated like in previous months, and you can sort and you can filter, and it also has like a main topic and then also like a more refined subtopic. So if you're looking for problems of a specific type, you can find those. You can look in there specifically and see which months and which worksheets have those kind of problems. But otherwise, good luck as you are studying for the Digital SAT Math exam. One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are 2 versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants in the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. And all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the Digital SAT Math section using Desmos.